All right, welcome back. In this lesson, we're going to be talking about the solubility of ionic compounds and how you can predict whether or not a compound will be soluble in water using a solubility chart. The word solubility means the ability of a substance to dissolve in a solvent at a given temperature. Remember that the solvent is the thing that does the dissolving, and the substance that dissolves in it is commonly referred to as the solute. When the two combine, we say that it is a solution, if the solute dissolves. When a substance dissolves in water, specifically, the state is changed to aqueous, which gets this AQ ending. If a substance dissolves in water specifically, then it is aqueous. Think aqueous as in like aqua. Use the solubility table in the data booklet to determine if an ionic compound will be very soluble, then it gets the aqueous state, or only slightly soluble, then it gets the solid state in water. Using the negative ion as a starting place is often the easiest. Using the anion as the starting place is often the easiest. This is what your solubility table looks like. I'm just going to talk you through it, and then I'm going to do a couple examples with the solubility table. On the top row, you'll see that it says ion. If you're looking through the table, almost all of these ions are negative. They are anions, which is why this hint is here, because it's easier to find the negative ion in the top. The exception to this is going to be ammonium, which is NH4+, and group 1 ions. Group 1 ions are any of the ions that come from the elements in the first column or first group on the periodic table. So group 1 ions would be hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Those are our group 1 ions in that first column of the periodic table. Once you find an ion, then you move down the column to see if you can find your other ion. Most of the time, it's a positively charged ion that you're looking for. If you find your ion in the top row here, then that particular ionic compound is aqueous. And it would look like this in water. It forms a homogeneous solution. If your compound is in the bottom row, then it will not fully dissolve in water. A lot of the solute will remain solid, and it will look like this, very heterogeneous. And it's not really a solution. What is the solubility of FePO4 solid in water? First thing we need to do is figure out what our ions are in this ionic compound. Phosphate always has the 3- charge, which means that because we only have one iron ion here, it must have the 3+ charge to cancel out this 3- charge and make a balanced ionic compound. This is our cation, this is our anion. You need to know both of your ions before you can use the solubility table. I'm going to write that down. You need to know both ions to use the table. It's important that you find out what the charge is on an ion that comes from an element that is multivalent. For example, Iron can have the 3+ charge or the 2+ charge. You'll notice here that if the iron was paired with fluoride, that if it was iron 2, it would be in the bottom. But if it was iron 3, it would be in this section here. We've got phosphate circled here. That is our anion. So we found our anion phosphate. Now we travel down the column and we see that the first row says group 1 ions or ammonium. That is not iron 3+, so we're going to travel down here. Iron 3+ is going to have to fit in this most category because it is neither ammonium nor a group 1 ion. Because this is in the bottom row, we're going to say that this compound is solid. It is slightly soluble in water. We can write slightly soluble and we will write FePO4 will remain solid. The next question asks, what is the solubility of silver sulfate in water? This compound you're not going to find very easily, and the main reason for that is because it's actually incorrectly listed here. You should see on your periodic table that silver is going to have the 1+ charge. So I want you to actually fix this right now. This should be Ag2SO4. The reason for that is because silver should have the 1+ charge and sulfate should have the 2- charge. So we're going to need 2 silvers for every 1 sulfate. We will solve this question the same way by first looking for our anion, which is right here, sulfate, then going down the table. Again, we have now, silver is not in this most category because it is explicitly stated here. Because we have silver explicitly pointed out in this column, in this row, sorry, in the bottom row, for sulfate, this compound must be slightly soluble. So we're also going to say that this is slightly soluble. Both of these examples end up with a compound that is slightly soluble. So let's take a look on the next page for some that are very soluble and will get their state changed to aqueous. What is the solubility of the following compounds? AQ or S. Remember that the S is going to be for slightly soluble. Really it means solid, but slightly soluble compounds will get the S, and the aqueous is going to be for very soluble. Let's work through some of these here. Sodium hydroxide. This is our cation, Na+, and our anion, OH-. I'm going to flip back to the last page and check out our solubility table. OH- is right here. There's our hydroxide. We'll move down. Group 1 ions or NH4+. Sodium is included in a group 1 ion, which means that we are in this top row. Because we're in this top row, this is very soluble. So if NaOH was placed in water, then we could change the state to aqueous because it is very soluble. We'll do one more. In this compound, our cation is calcium, Ca2+, and our anion is sulfate. We'll take a look at our solubility table. We'll find sulfate, and we'll track down. In this section, calcium is specifically pointed out as being in the slightly soluble category. So this will keep its solid state if you place it in water, whereas sodium hydroxide will become aqueous or dissolved in water. Sometimes, I just want to zoom in on 2C, you will end up with a compound where the anion is actually not on the solubility table. Most of the time it is. But if you're looking at a solution of sodium sulfide, sodium is Na+, sulfide refers to the element sulfur as an ion, or S2-. The formula for sodium sulfide is going to be Na2S. Let's look at the table and see if we can find sulfide as one of our anions. Looking across the top, we have sulfate, we have sulfite, but we do not have sulfide, or S2-. In this situation, it's actually the cation that allows us to determine the solubility, because this first column here has group 1 ions, including sodium. So now we're actually going to track down here, and you will see that we do not have specifically mentioned in the bottom sodium sulfide. Most things are aqueous with sodium, so this is going to be an aqueous solution. I would encourage you to do the rest of this practice, and in the next lesson, we're going to talk about how we name acidic compounds and basic compounds, and some basic differences, some simple differences, I should say, between the two.